Okay, so when you see all these videos of humanoid robots, it's pretty hard not to be blown away, right? But with Tesla's Optimus, there's this feeling that a lot of people are missing the real story. We see the demos, we make snap judgments, but what's going on under the hood? Well, that's where Tesla's hiding its secret weapon.
And you know what? It's a totally fair question. I mean, you see these absolutely wild videos from other companies, and then you look at what Tesla's showing off, it's really easy to come to the conclusion that maybe they're falling behind.
And it's not hard to see why, right? Look at the competition. You've got Boston Dynamics' Atlas doing literal backflips. Figure 02 was already on the factory floor at BMW. Unitree's bot is doing martial arts. And then there's Optimus, folding laundry and sorting batteries. It doesn't have the same wow factor.
But here's the thing. Judging them based on these tasks is kind of like calling a chess match after the very first move. It's a surface-level view that completely, and I mean completely, misses the single most important difference in their entire strategy.
So what is that difference? Well, it's the hidden key to this whole game, and it all comes down to the hands. Seriously. The dexterity, the complexity of the robot's hands, that's where the real battle is being fought.
Okay, to really get this, we need to talk about something called degrees of freedom, or DOF for short. Now I know, it sounds super technical, but it's actually pretty simple. All it means is the number of independent ways a joint can move. Think about your own hand. Your wrist can tilt up and down, side to side, and rotate. Each of those is a degree of freedom. Your knuckles bend, that's another one. So, long story short, more DOF means a more complex, more capable, more dexterous hand.
And this is where you see the two strategies just completely split apart. A human hand, which is, the gold standard, has about 27 degrees of freedom. Tesla's Optimus is aiming for 22. 22. That is ridiculously close to human-level complexity. Now let's look at the others. Figure 02 has 16, and the super athletic back-flipping Atlas from Boston Dynamics, its hand is basically a gripper with only 7. This massive difference isn't a mistake. It's a huge fundamental choice about their entire approach.
So what this really shows us is that there are two totally different strategic bets being placed here. This isn't just about who can make the flashiest demo for YouTube today. No, this is a fundamental clash of philosophies. Are you building for the AI we have right now, or are you building for the AI we're going to have in the future?
All right, so let's break this down. It's really two competing philosophies. On one side, you've got the competition, and frankly, they're making a really smart, practical bet. They're building simpler hardware, like that 7 degree of freedom gripper, because that's what today's AI can actually handle well. It gets them into a BMW factory right now. It's about product market fit today. But then you've got Tesla. They're making a completely different, much riskier bet. They're building the super complex, future-proof hardware, basically gambling that AI is going to get way, way smarter and will eventually need a body that can keep up. Now, if this whole strategy of building hardware that's way ahead of the software sounds familiar, well, it should. Because we've seen this exact movie before from Tesla. It's the playbook they ran with their cars, and it worked out pretty well for them. Just think back to full self-driving. For years, Tesla shipped cars packed with advanced cameras and sensors that the software couldn't really use to its full potential. The early FSD versions, they were rough. People criticized them a lot. But the key was, the hardware was already there, in millions of cars. Then, update by update, sent over the air, the AI got smarter and smarter, slowly unlocking what that hardware could really do. This is the exact same logic, the same game plan, just for Optimus.
And this really gets to the core belief of their whole strategy. It's the idea that the AI will catch up to the hardware. The hardware, the physical body, is the hard part to change. So you build the most capable body you can imagine, and you bet that the software, the AI brain, which improves at an exponential rate, will eventually figure out how to use it.
So why is this such a big deal? Why does this all matter? Well, because if Tesla's bet pays off, this strategy doesn't just put them in the lead. It creates what you'd call an unbeatable long-term moat. It's a competitive advantage that's incredibly difficult for anyone else to cross.
Let's make this real. Imagine you want to teach your robot a new, super delicate skill, something like threading a needle, okay? For a competitor, with a simple gripper, that's a nightmare. It's a hardware problem. They'd have to go back to the drawing board, design a new hand, manufacture it, and then retrain their AI from scratch for this new hardware. It's a huge, expensive process. But for Tesla, if their AI gets smart enough to figure out how to thread a needle, it's just a software update. The physical ability was already there, just waiting to be unlocked.
And there's a second part to this moat, and it's a big one: data. Tesla is going to deploy thousands of these robots in their own factories first. Think about that. Every single task, every object they touch, every mistake they make, all of that generates massive amounts of real-world data. That data gets fed back into the system to train and improve the AI for all the robots. This creates a powerful feedback loop, a data flywheel. The more robots you have, the more data you get, the smarter the robots become, which lets you deploy even more robots. It's a cycle that will be incredibly hard for competitors with just a few bots in a lab to ever catch up to.
So when you put all the pieces together, you start to see the bigger picture. Tesla isn't behind. They're not even playing the same game. They're playing a much, much longer game. They're willing to sacrifice the flashy, wow demos today for what they believe will be total dominance down the road. They're building for the future, not just for the present.
And that really leaves us with a big question, doesn't it? You've got this practical, get-it-done-now approach that's putting robots to work today, and then you have this incredibly ambitious hardware-first strategy that's shooting for the moon, aiming for near-human capability. It is a fascinating clash. But it really makes you wonder, by the time we get to 2030 and look back, who's going to be the one playing catch-up?